Let me try this again.
Cool. Thank you everyone for your patience. And if you have any questions, we use the Q&A and I will read them aloud.
All right. One more time. Okay. Share screen. Screen one. Let's go. All right. Now do you see the main titles?
Yeah. Yes. Thank you.
Awesome. Okay. So, thank you so much for inviting me to give this talk. Thanks especially to Alexis for thinking of me. I am the assistant public historian, at least for now, at the Center for History of Physics at the American Institute of Physics. And I will be talking to you about our resources and how the Center for History of Physics can help teach a diverse history of physics. So a little bit of background, because you may not have heard about the Center for History of Physics before. It is part of the American Institute of Physics, much like the Statistical Resource Center or the Society of Physics Students is also part of the AIP. It began in the 1960s, sort of was born out of this oral history project to collect the stories of the first generations of physicists working in quantum mechanics. But its mission has expanded since then, although we do still do oral history with a big part of our mission and our project. We are very closely linked to the Niels Bohr Library and Archives, which is also part of the AIP. We're not exactly the same, but we do 80% of our activities together. So if you're not sure who we are, but you're thinking of the NBLA, you're probably pretty close to accurate that we're almost the same thing. The picture on the right is just a fun one that I wanted to pull. It's of Nancy Roman, who's conducting some research at the Niels Bohr Library and Archives. You can see a bust of Niels Bohr himself in the background. Then, to begin, let's do a little experiment. I ran this experiment yesterday, but I've done it a couple of times over the years. And it's just to do a Google image search for the word physicist. The pictures that you see here are certainly a lot better than they used to be. I've done this little experiment various times over the years. And of course, you see some of the people you would expect. There are multiple photographs of Einstein. There's one of Freeman Dyson. But it's not all, people you would expect. There is Sabine Hossenfelder, Michio Kaku, Sylvester James Gates. So it's definitely a little bit more of a diverse representation than it used to be, although you can sort of see some things that I might, have a bone to pick about. For example, the second photograph of a woman is actually a stock photo, and so on and so forth. But then what happens if we Google historical physicist? Now, these images are essentially what it used to look like a few years ago if you just Googled physicist. And this is a much less diverse representation. We have multiple photographs of Newton, Galileo, Einstein, a nice little photograph of Heisenberg and one of Maxwell. And we have one photograph of Marie Curie and one photograph of Edward Bouchet. Edward Bouchet, in case you're not aware, was the first African-American to earn a PhD in physics in the United States. So as you can see, the history here is still pretty whitewashed. If we take Google as sort of our measure of common understanding of what it means to be a historical physicist and who was a historical physicist. Now, what is the Center for History of Physics doing to try to change this? One of our main activities is what are called the teaching guides on the history of the physical sciences. They used to be called something slightly different a few years ago, the teaching guides on women and minorities, but I'll just call them the teaching guides in this talk for short. They began in 2013 when we started a project to produce a large amount of educational materials covering the history of women and underrepresented minorities in physics, astronomy, and the related sciences. We've created a few every year since 2013, and now there are over 50 teaching guides online, plus 3 educational games. I want to emphasize, as I always do when I give a talk like this, that these teaching guides are available online for free to anyone. We highly encourage people to go and download any and all aspects of these and to incorporate them in their teaching. Everything that you would need for a teaching guide is available on our website. You will not find anything behind a paywall, but you might need to use one of them. It's all freely available. How are these teaching guides made? I said that we make a few every year, and that's because we bring in interns from the Society of Physics students every summer. It's a collaboration among the Center for History of Physics, these SPS interns, some graduate research interns, and teachers who have worked with the lesson plans. The interns create a few new guides every summer, and we also make updates to some of the older guides. For example, we try to make them integrate better with new science curricula. We also try to incorporate feedback on them. Maybe we'll update the history if some new research has come out, that sort of thing. The 2013 team started off with material relating to the history of women in physics. The 2014 team made materials relating to the history of African Americans in the physical sciences, and so on and so forth. So every summer, a few more teaching guides on a few different topics are added and improved and built upon. And so here pictured are some of the interns at work. At the top are the SPS interns and graduate research interns from 2014. The bottom left and right are from the summers of 2015. And that's actually me on the bottom right, demonstrating one of our educational games, which I'll talk about in a second. So where can I find these teaching guides? Well, they're on our website. If you go to the Center for History of Physics website, there's a menu option that says teaching guides. And from there, you can search all the teaching guides. You can do it by the physics topic that you're interested in, like inertia, or a history topic like civil rights. At the end of this talk, I'll go through navigating the actual website at the end so you can see what it's like, and we can look at a teaching guide. And I've got the link at the bottom of the screen. Don't worry about trying to take notes or copy anything down. I will share these slides with Alexis after the talk, so you don't need to worry about making sure you get the link exactly correct. Now, let me tell you a little bit about the guide sort of in general. The way we try to incorporate a more diverse history of the physical sciences is to try to tie learning science and history together. We want it to seem like a natural insertion into a science classroom or into a history classroom. You can use these in any kind of classroom you want, but we don't want it to seem like an artificial addition, right? You know, these are people or episodes in the history of physical sciences that are part and parcel of the fabric of science and the fabric of history. So we don't want it to seem like it's trying to be wedged into the course. It should feel very natural. The guides are written for specific age ranges, from K through 12 through college. Most of the guides are directed towards 9th through 12th grade and college ages. And sorry, that is my adorable baby in the background who has his own commentary to share. But these can be adapted for use in age ranges beyond what they were specifically written for. For example, one of the most valuable parts is every teaching guide begins with an introduction to the history. So you don't need to be an expert in the history of Eunice Foote, the climate scientist, to teach about her. We give you the whole history, essentially, that you would need to know. And that kind of introduction will help set you up for adapting a lesson plan or creating your own lesson plan about that historical topic. Each teaching guide and the corresponding lesson we outlined is written with the 5E model, which stands for engage, explore, explain, elaborate, and evaluate. It's pretty intuitive how to follow it, but again, we encourage people to take these and make them their own. It's not necessary to follow that particular, step or that particular model in order to get something out of the teaching guides. And so I can tell you a bit briefly about these two examples, and then at the end, I'll take us to look at one in more depth. So the top one is about inertia, from Ibn Sina to Newton. So in this lesson plan, students would learn about the history of the Islamic Golden Age and why it was so important to the history of the physical sciences. And then it takes one particular concept, inertia, and talks about how that changes from the Persian polymath Ibn Sina to how Isaac Newton conceived of it to how modern day textbooks conceive of it. So it should fit very naturally into what would normally be a Newton's laws kind of class, and make it into a class that's covering, that concept that students need to learn, but with a much more diverse history in back of it. And the bottom one, Eunice Foote, climate scientist, is about a 19th century woman who was the first to observe and document the greenhouse gas effect. And in this lesson plan, we actually have 3 about her, because she had a very fascinating, very multifaceted life. You can recreate her greenhouse gas experiment and see what it was like, and also learn about her history, of course. So do not worry about reading this slide. This is for impact, not information. This is the list of all of the different teaching guides that we have online currently. And if you do want to pick out a few to read, we have a wide variety of ones that focus both on a little bit more on the science, or ones that focus a little bit more on the history. And they're quite fun to browse, and you never know what you might learn. So for example, we have a lesson plan about Emily du Châtelet and concepts of gravity, about Luis Alvarez, about Anthony Johnson and his work in optics, about the Tuskegee Weathermen, including one specifically about Charles Anderson. You get the idea. Our collection is especially strong in the 19th and 20th century history, and in topics related to optics and nuclear physics, but there is a range, and we are trying to expand in areas that are not well covered currently. Next, let me turn our attention to the 3 educational games, because these are very fun, and games are a great way to sneak in some knowledge and some history into lessons. The one on the right with the portraits of individuals, names, and dates is from our Heads Up game, which is the same as a regular Heads Up game. You put a card to your forehead. You don't know what individual is on that card on your forehead, but other people can see it, and they will try to give you clues. And if you play this game after teaching with our teaching guides, students will be a little bit more able to give clues as to these people. So for example, if I were holding up a card that said Hertha Marks Ayrton to my forehead, someone might say to me, oh, she lived in England and she worked with electricity and sea waves. And we have a lesson plan in which we talk about Ayrton and her work on waves. So there you go. The one on the bottom left is an image of our game called Scientists of Catan. This one is really mostly just for fun. If you've ever played the Settlers of Catan, it's a parody of that. So in Settlers of Catan, you create a settlement and you expand your settlement against other players or with other players using various resources at your disposal, like rocks and wood and sheep. But here you are a scientist, and you have to expand your career as a scientist using the resources at your disposal, which are time, ideas, grants, and graduate students, and citations. So with these games, we aren't able to give you the actual physical materials. We can't give you cards for Heads Up or the tiles and the game pieces for Scientists of Catan, but we have online all of the information you need to build the game, to print out the pieces yourself. So everything you could need except the paper to print it on is available for you. Next, I want to go into our third game and play a little bit of a game right now, and that's Fistory, which is a variation on chronology. In this one, we have cards with dates on them and events in the history of physical sciences. I'm particularly proud of the expansion that we've added, which focuses on the period before 1500. That means before the scientific revolution, and has a nice focus on the Islamic Golden Age. And this is a really great way for getting people excited or thinking about different events in history, how they line up, and inspiring people to do a little Wikipedia search. If you've never heard of something, but now you've heard about the Samarkand Observatory, maybe you want to go look it up, add it to your bucket list to visit at some point. So how this game works is everyone starts off with one card that they can see the date on it. So here on the right, card A is Yahya ibn Abi Mansur dies. He produced the first Arabic astronomical tables independent of Greek originals. And so we can see that the date on there is 832 CE. All of these dates are CE, Common Era, unless otherwise specified. But then we are told another event, which is the Samarkand Observatory is built in what is now modern-day Uzbekistan. This observatory was best known for its large underground sextant that had a radius of 40 meters. The sextant was used for making meridian observations. So now we have to decide, does card B go before or after card A in our timeline? And if we guess correctly, then we get to keep the card. So I'll give you a second, think about it, and then reveal the answer. So the Samarkand Observatory was built around 1420. So it actually happened quite a bit after card A. And you can see, as you start off with a small timeline, it's pretty easy. It's either before or after. If you're not sure, 50-50 guess. It gets a little bit more complicated once you start adding more cards to the mix. So now we have card C. The classic period of Mayan civilization ends. During this period, a calendar was developed called the Long Count, based on a 360-day year. So where does card C go in our timeline? Before card A, in between card A and B, or after card B? So think about it, jot it down, take a guess. Here we go. It actually goes in between cards A and B and happened around 900 CE. So the Mayan civilization is quite a bit older even than the Samarkand Observatory. All right, and one more, and then we're done. I love this game. I could play it all the time, but I know we have other things to talk about. So for our final event, let's see if we can place when Ptolemy was born. And card D says his model of the universe was used for astronomical calculations for over 1,000 years. So where does card D go? When was Ptolemy born in relation to these other events? So think about it. 3, 2, 1. Okay, Ptolemy was born around 90 CE. So he is by far the oldest event in our timeline. And this game usually can go until you create a timeline of 10 cards, or you can make your own stopping point as you see fit. But you can see how the game goes, and I found this to be very addictive for students when I've introduced it to undergraduates. They get very into it. So then next, let me talk a little bit about some of the other kinds of resources that we offer. We have a Trimble public lecture series, which is free. It's always either completely virtual or streamed live online. We actually have one coming up this Wednesday at 3 p.m. Eastern Time by Maria Rentetzi. She's giving a talk called Making Radium Kinky, which is all about how radium ended up in various popular beauty products and pharmaceutical products, and how it became a quote unquote hot commodity, if you'll forgive the pun. But almost all of our lectures are recorded and then put online on our YouTube channel, and some of these lectures are probably of big interest to this audience. So for example, the last one we did in November by Bruce Hunt was a very good example of how the history of racism, colonialism, is just inextricably linked to the history of the development of physics. Very often, I think people sort of assume that physics developed in a completely separate and objective way, perhaps in parallel to the history of racism, sexism, bad stuff, but not necessarily linked to it. And in his talk, he talked about how the development of Maxwell's equations cannot be separated from the history of the British Empire and its colonialism. So that was a super interesting talk. It's available on our YouTube channel, as are Simone Turchetti's talk about the International Geophysical Year and the lessons that that has for international scientific collaborations in the wake of colonialism. We had Amy Bix's talk about the history of movements to get more women into STEM. And we also had a talk from Katamari Rosa about how the history of science and our understanding of it has been influenced by the history of colonialism and racism, and how that has shaped our understanding of what scientific knowledge even is and who has it. We have web exhibits. Most of them are not terribly of interest for diversity, equity, inclusion, although we do have an exhibit on Marie Curie, but they're very interesting. One of our more recent ones is one in the history of oceanography, the voyages of the research vessel Vima. So it's pretty cool. Of great interest, though, is our first season of our podcast, Initial Conditions, which was made by the Niels Bohr Library and Archives. And that focused especially on lesser known episodes in the history of physics. And two episodes that I highly recommend are one about the Hawaii and the 30-meter telescope, and one about historical romance and LGBTQ plus representation, which is about romance novels and about the history of Carolyn Herschel and Mary Somerville. And it's also a very interesting, fun episode and just a fun podcast on the whole. And oh my goodness, we have so much more to offer. So we also have a newsletter that's published twice a year. We have our oral history collection, which I mentioned at the very beginning, but that's not just, you know, the well-known names and faces of the history of physics, although we certainly have many of them in there. These can also be great for showing students how the history of physics is made by many different people from many different backgrounds who go through their careers in many different ways. History is messy, life is messy. Never assume that you can't be a physicist because your life isn't perfectly put together. Our oral histories really show that that's usually never the case. And finally, we have grants and aid awarded twice a year for up to $2,500 for each applicant. If you have a student who is maybe writing a senior thesis about a topic in the history of the physical sciences and they need to go to an archive to do some research, we can fund that. That's what those grants and aid are for. So if you have, you know, any questions about these, anything that I've talked about or anything that I haven't talked about, I encourage you to reach out to the Center for History of Physics at chp@aip.org, or we have various social media handles. And again, don't worry about writing this down. These slides will be available afterwards. Similarly, for all of these links, these slides will be available afterwards too. So next, let me quickly go through how to find one of these teaching guides and the various aspects that are included in it. Okay. Now I gotta remember how to navigate my screen. Okay, so you should see the website for the Center for History of Physics pulled up. If you don't, someone please give a holler. I will now click on Teaching Guides in the menu at the right. And this brings us to our main Teaching Guides page. So if you scroll down, there's a section that says Educational Games. And if you click on the link here, Educational Games, that will take you to all the documents you need to play Heads Up, Fistory, and the Scientists of Catan. Now, let's say we want to browse all teaching guides. You can click on this link, and it just brings up a list in alphabetical order. The Black Scientific Renaissance of the 1970s through the 90s, African-American scientists at Bell Labs. That's a very nice one. And if we go back, we can also search all teaching guides. Let me bring us to the one with Eunice Foote, since I talked about that one before. I'll just search for greenhouse gas. That should bring it up. Okay, and here it is, Eunice Foote and the greenhouse gas effect. And you can see below here one of the other teaching guides we have about her, Eunice Foote, scientist and suffragette, because she was also very involved in the first wave, first movement in the United States in the sort of the late 19th century for women's rights. She was at the Seneca Falls Convention. So if we click on Eunice Foote and the greenhouse gas effect, it will bring up the teaching guide page. We have an image, we have a short description of the teaching guide and what students will learn through it. And the first link on here is the lesson plan. And this is what I was highly recommending, even if you think it's not, this is for grade levels 9 through 12, what relevance does this have for college age? Well, you can just scroll down and you'll see we have this introduction, which is they're always sourced, so you can trust the authoritative nature of the introduction. And it's not very long, usually it's about 1 to 2 pages, but it will give you a good enough background on the topic so that you can feel confident to teach it, talk about it with other people. Every lesson plan tells you about what grade level it's geared towards, about how long it might take in class, how much prep time it might take, the subjects, etc. What materials are you going to need if you want to do this lesson plan in its entirety? And then if we scroll down past the introduction, here's that 5E model with engage, explore, etc. And this really is supposed to take the guesswork out of doing the lesson plan. It sets out step by step. What is the teacher doing? What are the students doing? We really want to make it as easy as possible to incorporate these in your classroom. What reading or resources might you need? What kinds of discussion questions might you want to do when you're talking about the topic? Here's further reading and additional resources if you get curious. Related teaching guides if you want to do more about these topics. And if you are a high school teacher, the relevant next generation science standards or Common Core standards that are pertinent to this teaching guide. Then if we go back to this teaching guide's webpage, here are all the supplemental materials. So if you're going to do the laboratory activity with this lesson plan, you can print out the laboratory instructions, the laboratory worksheet. There's a reading handout you can give to the students, questions, an answer key to grade them, etc. All of the information, all of the resources you could possibly need are right here. So here's the laboratory instructions sheet to recreate her experiment. So it should be pretty foolproof, although knock on wood, you won't have too much difficulty if you want to try to use one of these. So I think with that, I will stop sharing my screen and open it up to any questions that people might have. And I hope these are of use to you, and if only that you take some inspiration from them for use in your own classrooms.
Great, thank you so much. I learned a lot. I was already familiar with some things on this. I didn't really share the games. As I had written in the chat, if you have any questions, please use the Q&A because it's easiest. But to get started, from my end, I was curious, which lessons seem to be the most popular ones that people implement?
It's a good question, and it's hard to tell, to be honest, because since there are no barriers or any login to track when people download our resources, we don't always know when people are using them or what they're using. We do track our website visits so we can see what pages are most popular. So at the very least, I know that a lot of people visit the Black Scientists at Bell Labs lesson plan, for example. There's one about the quote unquote hidden figures, Katherine Johnson and her colleagues at NASA. That one is also very popular, at least in terms of web traffic. But we do always love to hear from people who actually use them to get feedback and know if they're working or not.
Yeah, that's a good point. 'Cause I was also curious, related is, have you heard of any particular creative uses about how people are using all the wonderful resources from y'all? Because I was thinking with, especially with the games, I could see local Society of Physics chapters playing those because I know a lot of people like to play games. A lot of people like to use their SPS time to do all sorts of fun stuff that's still physics related.
Right. We took the games to PhysCon, which was held in DC last year, and the chronology game History was very popular. We played it, set up some table and played it with the cards, and we had so many people coming up, and we printed out a couple of packs and gave them away to people. So I certainly hope they're being used. Beyond that, one creative use that was brought to my attention a few weeks ago is that the introductions to the lesson plans are now being used as sources on Wikipedia, which is kind of surprising to me, but I think sad but good that they're available because they seem to often be one of the few resources that are out there for people to learn about a particular topic.
Yeah, and related to that, I guess, are there ways that folks can contribute to this? I know you mentioned that some of the things you have the interns over the summer, that there's ways if people are doing dissertation types or thesis type things, they can participate. But if, you know, someone out there has time, if they wanted to contribute, is there ways they can do stuff?
Yes, we have, I mean, if you have an undergraduate student who wants to do an internship with us over the summer, that's a major way to get in on the ground floor for sure. I have had other people reach out and say that they are using this as actually a classroom activity or a classroom sort of final assignment, that someone will try to write a lesson plan and in the style of these to learn about the history. It's sort of like a research project, but it can have an impact at the end beyond the class. And I think that's very nice. We do have resources that we can help give you a template to say, like, here's how we do it, and here's how you do the basic research that can go into making the lesson plan. And we can't, of course, guarantee that they will end up at the other end on our website, but I was very pleased to hear that it was an activity. I, love looking at them. And if they can make it up onto their website, there's no rule that says we will only accept ones that are made by, our particular interns in the summer, as long as they meet our standards and we see that there's definitely an opportunity there.
Cool. Yeah. And I guess based on this work and working with so many different types of people, were there any lessons that you feel like that you've heard? And I mean, I know that because the data collection on how people are using these stuff is kind of hit or miss, stuff that people should know before they implement these things, pitfalls that they might find themselves in or something, or, really good ideas to, scaffold this right.
Mm-hmm. Are you thinking pitfalls for people who are using them, or our own pitfalls? Because I have perspectives on both.
A little bit of both, because I'm just thinking history. I know people is a very so especially dealing with sort of DEI type stuff that can be a little fraud and people can have all sorts of
Sure.
reactions. And then it's also really hard to get good accounts of stuff too, sometimes too, as like a
Right.
researcher.
Um, yeah, I would say that the pitfalls for people who are using these or who are sort of new to thinking about history and what that means for the present day is it can be all too easy to fall into this mindset of um, like the big individual driven history. Uh, Even if you're going into it from a DEI mindset and you're thinking, well, I'm not going to do the history the way it's always been taught with these particular heroes of Einstein and Newton and whatnot. You can still end up replicating that mindset without being aware of it by choosing. I don't know. It happens so often. I see with Marie Curie, for example, like she essentially becomes like Einstein, but with a different face and gender. So it's not really rethinking the structures of power or how history is done. It's still falling into this trap of physics is only done by great and exceptional individuals. And sometimes they're women. That's not really revolutionary. What's more revolutionary is to think about people as more, it's more flawed. History and science is a much more communal activity, which is true even for these quote unquote great individuals. Marie Curie did not work in a vacuum, um, and there's more to history than just Marie Curie. Although of course I see the attraction of doing a project about someone you've heard of, but history is much bigger than that and much more interesting.
Yeah, that's really interesting because it has me thinking about how these things could be leveraged to do cultural shifts and how we perceive science and things like that. Do you have
Right.
an, I think besides, bringing up these ideas, are there other tips or techniques you have to sort of shift the mindset of the lone hero type person or heroine?
Yeah, I think it's to look in places you don't expect and to look at kinds of sources you don't expect. And this is maybe getting more into how do we do historical research than people perhaps have time for or interest for on like a day-to-day basis, but it can be something to think about anyway. So when, for example, I do my research, I don't usually look at published papers for individuals because these tend to, you know, take away all of the doubt and uncertainty that comes with doing science. It's just one polished, result and methodology, and everything that led up to that is completely erased. So, I mean, I don't not read them, but what I find most valuable in looking at history is not looking always at like the published thing that's meant to give the best view of something. So maybe try looking in like a little bit of another direction. Um, and I'll take it back here to our oral history collection, which is very much about the messiness and all the stories that don't make it into the final published work. You're not going to find that in an obituary. You're not going to see that in a published paper. These oral histories are, people talking about, well, I tried X, Y, and Z and that didn't work. And then I tried this and that didn't work. It's people saying, well, I sort of lucked into physics. Their CV and their obituary might make it seem really natural that, they studied at this university and then there, and then they did a postdoc. But if you read the oral history, they're talking about, well, I kind of had to move over here to do this thing. So I wasn't really sure what to do. And then someone reached out and I just decided like, well, why not? I'll give it a try. So it's a very, very different perspective on things. And I think that's really helpful in moving away from like a very neat concept of science and history. It's easy, but it's wrong. So
Yeah, I totally understand what you're saying because I was thinking about how a lot of people you hear, like contemporary people, it feels like it's a very linear pathway into like they went to high school, they went to undergrad, they got their doctorate, and so on and so on and so on. And it didn't seem like there's much paying attention to their choices. They could have done X, Y, or Z things, anything else. It just seems like, oh, boom, boom, boom,
Mhm.
scientist done,
Right.
discovery done. Oh,
Right.
and as one last thing, is there anything else you'd like to share with us at this time?
Well, I could give an example because given the opportunity, I will absolutely talk about my research in the history of science. So, a great example to what I previously said about not necessarily looking at the published stuff is a woman I study named Dorothy Weeks. She was born in the early 1900s and was a professor for many years at a women's college called Wilton College. She worked in spectroscopy. She had an interesting role in sort of the scientific bureaucracy during World War II. She worked in astronomy for a bit. Her CV, if you look at it, it makes total sense. She did her uh, bachelor's at Wellesley and her master's and PhD at MIT, and she was the first woman to earn a PhD in mathematics from MIT. And it kind of seems very neat, but the more you dig into it, the more things don't make sense. You might ask, well, why mathematics? I thought she was a physicist. Yes, and she did her master's in physics, but the physics department chair at the time was very anti-women. So she actually left physics for a few years, started working in a department store, got a master's in working in stores, and eventually made her way back into science, but not to the physics department. She went to the math department. So like the more you dig into it, and her oral history is one of the ones that's in the AIP collection, it's very messy. It doesn't seem neat, and it's a much more fascinating life once you get past the kind of big events.
Yeah, thanks for sharing that story. That was really interesting because there's also, a lot of people even nowadays have messy lives. And it's important for us to remember that. I find it very comforting to know that you didn't have to have everything figured out on this nice linear path to be doing good things. And
Right. Given that I'm myself moving shortly, I feel like I really need to advocate for the acceptability or acceptableness of a messy life.
I feel like that should be like the new addition, that unexamined life is not worth living or things like that. Needs to be a new addendum about messiness in your life.
Right.
But with that said, I am going to stop the webinar. Thank you everybody for attending. We will be starting back up in